Hello everyone, this is the continuation to my previous video on Argo CD. In this video, I'm going to show you how Argo CD can be used in order to maintain a continuous delivery pipeline for your workloads running in a Kubernetes cluster. So in this demonstration, what I have used is a Minikube cluster. And over that Minikube cluster, I'm hosting my application, and over there, I'm going to utilize Argo CD. And this complete repository is currently available in my GitHub account, and I would be showing you how I'm making changes over there and how Argo CD is actually behaving accordingly in order to keep the desired state of the GitHub repo. The main application here is a Flask based application where it simply renders an HTML hello world page, basically simple HTML page, and a health endpoint that gives you the hostname and the IP address and nothing else. I have already created two images of different colors. So the base, the index.html one is a green application and the other is a blue application, and both of them are available in my Docker Hub repository. As you can see, for the deployment of this application in a Kubernetes environment, I have created a manifest folder, and under manifest folder, I have another dev folder. And over there, as you can see, this is a deployment YML where I have specified the container image as my Docker Hub public repo followed by the desired tag, say for example, green tag. And in the service.yml, I am using a cluster IP type of service in order to expose this application. How to install Argo CD and how to install Minikube, those would be available in the description of this video. But just for your reference, if you want to install Minikube, it is quite simple. Based upon your operating system that you are using, you can select and download the binary, or if it's a Mac based environment, Mac OS that you are using, you can directly use homebrew command. For starting the application, the cluster, you would need to use the Minikube start command. So without wasting time, let's come over here and I will execute Minikube start. So as you can see now, the Minikube is installed and it is coming up along with a kubectl command. I will just show you some of the basic things over here. So this is the command that I've used, which is kubectl get all and across all namespace. So this will give me an overview of what are the things that are currently running in my environment. As you can see there, these are basic important control plane components like core DNS, etcd, kubeAPI server, and controller, the proxy schedulers as well. And the corresponding services, the daemon sets and deployments, as well as the replica sets are running. No other application is running currently. Now you have to follow the steps as specified in the documentation of Argo CD in order to install the Argo CD, but that you can refer. However, if you refer to the README documentation of my repo, you will be getting the simpler steps. So the first thing is you have to create a namespace for deploying the Argo CD, which is Argo CD. So this is the namespace I have created. And after that, I can simply use this manifest file. So this is already available in the documentation of Argo CD, these steps, which is pretty much simple. So if I come over here and simply click on apply, and you can see that it has created a lot of different components, some of the custom resources, as well as the role bindings, config, max serve, service, important components required to run Argo CD locally. So if I now, under the namespace, get all -in and Argo CD, under Argo CD namespace, since I installed those components, let's see what all the things that are running. So there's a minor error that is coming up, possibly for the Argo CD Redis. So even you may ignore that, but let's see if it has resolved. Yeah, it was just a transient error that was appearing earlier. Everything is up and running. Now the main thing is accessing this. So how do I access this you have to use kubectl port forwarding command, and this is how you can access the Argo CD UI. If I use this now, what it is basically doing is the Argo CD server component, which is the UI component. I'm just using kubectl port forward to open one of the, or to map that port to port 8080 of my local host. So if I go over there and localhost 5000, sorry, localhost 8080. So it is giving me a temporary warning that since it's a HTTPS connectivity, I'm trying to access over port 80 without a proper certificate. You may ignore it, just proceed. And here is your Argo CD UI. For username, by default you would need to give as admin. Now for a password, there is a small tweak. You would need to get the password from the kubectl using the get secret command. So whenever you are installing this manifest file, it creates a secret object, and from the secret object you will just need to base64, you need to decode it. And in order to do that, let's create another shell terminal instance, and over there I would just paste this. So be careful with this, just you need to ignore the bash. Depending upon the type of terminal you're using, you just copy it and go over here and paste the password. So I'm getting some kind of a permission denied error. Okay, but yeah, no application is running in this case, so I'm not getting anything out of here. Okay, the next part is, so whenever you are creating, I have deployed Argo CD. Argo CD is available. My applications are also available. The images are available in my Docker Hub. Now the thing is, how do I create an Argo app, Argo CD application? So what is Argo CD application? So if you come over here, so it's a Kubernetes custom resource where you specify how Argo CD should deploy and how it should manage your application. So it is done with the help of a configuration file, but that configuration file is that's an application YML, that's a YML file, manifest file, but I'm using Helm in this case in order to install the application. And in the values section, if I show you, is where you specify the source. The source is my GitHub repo account. The target revision is main. This is where the main branch name you would need to specify. Destination is the Kube API server, which is the Kubernetes service that runs locally, and the application, that this is going to be my application name, and the manifest would reside in this folder, which is manifest/dev in this repo, which is basically these YML files. And I'm specifying that, hey, let's create a namespace and you deploy the application on that namespace. Talking about this template.yml application YML, which I was referring to, it has this component. The type is, the API version that you would need to use is argoproj.io v1 alpha 1. So you have to be careful whenever you're using any Helm charts about the API version. So this Helm chart is readily available in the documentation of Argo CD. And here is where the 4 important components projects. By default, the project should be marked as default. This is where the source lies, where you are connecting, you're specifying the repository URL, the branch version, etc. And destination is where your Kubernetes Kube API server is running. And there is the sync policy, like what is the frequency of the synchronization that you want your Argo CD to refer to the GitHub repo and make those changes accordingly to your cluster. This is where you specify. Okay, now it's time for deployment of this chart. So this is what the command that I'm going to use. I need to give a meaningful name over here. Say lnuse argo. This is just a simple helm command, and as you can see that I have just installed it, and if I go to my console, you can see that now lnuse app has been launched over here. So this is a configuration file, and it not only that, it has you referred to the original manifest file that is currently available, where this is the one I'm referring to. Let me show you the manifest or the manifest dev file, and in the deployment, so it is supposed to use the green tag. So let's see over there whether it's using the green tag or not. Yes, it is using the green tag. Now if I want to access this from my local environment, how would I do that? Even again, for that I will be using the port forwarding endpoint. I'll just copy this, and let's first of all see the pods that are available. kubectl get pods -n, and the namespace is learnuse namespace. So these are the number of pods that are up and running. Now if I try to get hold of the service name, is vc-n, this is the learnuse-service. So I'm going to use the namespace is lnuse, and the port that I'm going to use is 5000/5000 :5000, and the name of the service is lnuse-service. So this is the command I'm using for port forwarding. Now that port 5000 is up and running, I will try to access the port. So this is my green application which is running, and even if I'm trying to check the health of this application, as you can see, which is 10.2f244.0.11, it is the internal network range of the Minikube cluster. So in case if you want to, I just need to create another terminal instance because 2 port forwardings are up and running. And over here, if I try to get kubectl get pods -n learnuse-o wide. So this is going to give me the complete IP range as well of the pod, and the request has been processed by this pod, which is 10.244.0.11. Okay, now let's go over here, and in the manifest file I will make a change. The manifest file, the change that I'm going to make is I will going to change this from green to blue, and git status git add -a followed by, and over here I'm going to pass update to blue app, and then followed by git push. As soon as I make a git push over here, you will observe that, so generally the syncing, depending upon the type of syncing strategy, it generally takes 3 minutes. At a 3-minute interval it tries to make the corresponding syncing. However, you can quickly sync it as soon as possible as you want. So I will just proceed over there and go with synchronization. Now you can see what it has done is it has created another replica set under the same deployment object, and under that replica set it has created 2 new pods, and you can see the status of these two, the older pods which were running the green container, they are now gone, they are now terminating. And now over here with the blue tag, this application is up and running. The status, the sync status and the health status, everything on the left side you can also monitor on the left side panel. And the UI feature that Argo CD provides is also really good. depending upon like how you want to view it. Now let's try to access this endpoint. Now if I try to access this, let me see if I would be able to access. No, currently it is down. I would need to go back again, and since the connectivity to the pod got lost because it is no more available, I will run the same command and I will 10.244.0.12, and if I omit this health, now you can see it has changed to blue color, which is the now pointing to the blue app. Now just to validate again, kubectl get pods -n -o wide. So the previous request of health endpoint 10.244.0.12, so it is actually pointed by the response was attended by this specific pod, this pod. So in this way, Argo CD helps you with the continuous syncing of your application based upon the changes that you're making to the Git. Just to showcase you now, I will try to initiate a scaling and scale out event directly using kubectl command. This is an incident where I am trying to scale out. So current number of replica is 2. I'm trying to initiate a scale out event. If I do that, now as you can see, I have executed the kubectl the scale command where I have put the desired count to 5. You will see there are additional instances that were initially that has been spun off, but based upon the single source of truth, which is the Git, the replica count is supposed to be 2. So it is ensuring that the count is always kept as 2. And as you can see, those pods, newly created pods, they have been terminated. Now let us try to create a scale in behavior. I would initiate the scale out, the scale in behavior to 0. Now it would try to terminate the old instances, terminating the old instances, but despite that, since I executed the command twice, it has deleted the older instances that were running for 4 minutes, and then again few seconds back I again executed the other command. It has terminated those two, and again now it is ensuring that the new only 2 pod instances are up and running. So this is how even if you are trying to access your cluster, trying to mess up with kubectl command, anybody is trying to do that, Argo CD would ensure that the state is preserved, referring to the old GitHub rep, referring to your Git, whatever you have mentioned. So in this way, Argo CD acts as an excellent mechanism of maintaining your application in a continuous delivery pipeline, and is indeed an excellent tool in a Kubernetes based environment where you're running your workloads. So thank you everyone for watching. If you have any questions, if you have any feedbacks, just reach out to me and refer to the GitHub repo that I have used. Try it out, give a proper hands-on. You would definitely love it. Thank you for watching. Have a great day ahead, and cheers and good night.